All right, so here is some partial fraction decomposition with sageMath. Actually, sageCell will be doing it in, but sageMath is the thing that runs sageCell. So what I did was I went here. I should make this a little bigger. So I went here and I typed in sageMath partial fraction decomposition, because that's just what I tend to do to try to find out how to do things. I've done partial fraction stuff before, but I couldn't remember. I knew it could be done. And so I didn't look at this link. It probably would have been a good one. Well, let's go there now. So if I go to that one, then here is some stuff. Let's make it a little bigger. Let's see. So it says here this denominator should produce 5 fractions. Now, where are they getting that? Well, x squared plus 1 is irreducible, so that's 1 fraction. And then we have an x cubed minus 2. Oh, they're talking about complex numbers, because I was going to say, well, they've got an x cubed minus 2. That should be no more than 3 fractions, so total that would be 4. But they said 5. Well, they're allowing this to be factored in the complex numbers. So you know, you can look down this thing, and here's the key. There, you need to do the partial fraction. What they do, they said f is x cubed minus 2. Then they did some things. I think all this has to do with doing the complex numbers, so I'm not worried about that. Here they said factor f. Well, that's nice to know that we could factor f. And when you factor f, I guess this first one didn't produce anything. Now, when we look down below it, you know, so these are things you need to realize that, you know, could be going on in a given technology. So it didn't factor it at all. Yet, when they said factor it over the complex numbers, well, there's a real factor. Okay, and then we've got 2 complex factors after that, but that's a real factor. So why didn't it do it up here? Well, my guess is that is a truncation of an irrational number. So when you ask Sage to factor something, it probably tries to factor it in the rationals. Okay, so it didn't factor that. Now, can we use anything else? Not too much. It doesn't look like. Here I go down, I look at answers and so forth, and I look to see, you know, what it's doing. I don't really see anything where it's, here it's using the partial fraction decomposition. Now notice that's a little different. Partial fraction decomposition, that is different than wherever he had it up here. Somebody had a partial fractions, I thought. Yeah, no, partial fraction decomposition. Yeah, all those use this command, partial fraction decomposition. Now, but let me show you what I had gone to first. That was there's the first one. Now I went to this one. I didn't really see anything that I wanted. I skipped that one, and then I went to this Sage Notebook partial fraction decomposition, and I go here and notice this one. Again, make it bigger. This one, you know, they say, oh, okay, they defined f and they actually put in the A, B, and X in here. You don't really need to do that. We'll see that in my example then. But they just said, they set F equal to this fraction here, and then did partial fraction, not partial fraction decomposition. So that's the thing that I found. And notice down here they start talking about Laplace transform, inverse Laplace transform. That's something to keep in mind. And go back here to sageCell. So I went to sageCell and I did our problem from my original partial fraction video. So first I declared x and y to be symbolic variables. I didn't need y, I guess. I don't know. I guess I'm used to putting x and y. Let me just get rid of that, just to point out that we don't have to have that. I just use x in here. So so I define x to be a symbolic variable. Then I took that x minus 2 divided by x minus 1 times x plus 1. Notice lots of parentheses to make all this work. And I set that equal to f, my fraction. And then I said show, so I could see it, f dot partial fraction and of x. Now in this case, where all I have is x and some real numbers, I don't know that I need that, and we can experiment real quick and try that. But so I'll evaluate this again, just to show it does evaluate. And there's our answer. Remember, we got 3 halves, x over the x plus 1 and a minus 1. Oh, actually, I think that's backward of what we had, so maybe I had an x plus 2 in there. For some reason I'm thinking that's backwards. The numbers look fine. Yeah, I think that's what we had. So I must have had an x plus 2 up here. So we get our 3 halves over x minus 1 and a negative 1/2 over the x plus 1. So we get those same numbers, and there you go. That's it. I could actually hand that off to something else. So I could say P equals f dot partial fraction of x. So I'll get rid of that there. And then I could say show P and evaluate. And when I do that, there's my answer. So I could do it that way. Now let's experiment. See if I can get rid of that x in this case. Evaluate. And it works, right? Because x was the only possible variable that could be there. Now if I do toss in, like, well, let's do an a, and I'll make that x minus a, this may still work because it may default to x, but I don't know. Let's see what happens. Yeah, it seemed to be happy with that, but to be careful, I think a good idea would be to say, yeah, that's x. Oh, interesting. I got a different answer. Now, and notice, let's go back, and so it may matter a lot that x is there. Because notice, if a equals 1, here I get 3, and here I get a 2, so that's 3 halves. And I get 1 minus x, but a minus out in front, so that'd be positive 3 halves over x minus 1. So that is the correct answer if a equals 1, as we had, and this one is a minus 1/2 over x plus 1. So that's correct. So let's take that x out of there. So I might have spoken too soon that works. Yeah, notice it didn't do it. I didn't even notice that the first time, but it did not do a decomposition. And so yeah, you need, with that a in there, it doesn't know what to do, so it didn't do anything. Okay, so we need that x like that. Now we can try something else, and so I'm going to do a show, and I'm going to take this thing. I'm going to add some more parentheses like that. So notice the green here and there, that's all inside parentheses. And then I'm going to add that on the end and then close off the show. And so here I didn't bother handing that expression to anything. I just put parentheses around it and said do a partial fraction of it. Let's see what happens. And there you go. It worked both ways. However, I think it's a little cleaner to do this kind of thing up here. Okay, so that is creating a partial fraction. Now, let's try that decomposition. Again, it's very quick to experiment. You may find something doesn't work. Decomposition, it was. Okay, I believe it was underscore decomposition. So let's just see what happens when we do. Okay, so didn't like that. What did it say? Symbolic expression has no attribute, partial fraction decomposition. Okay, I'm going to look back really fast, and now that one has it empty. So let's just, again, we'll try an experiment very quickly. We'll just put a 1 in there, and we'll take out that x, and we'll see, does that do any better? No. Okay, so I'm not sure what this partial fraction decomposition is. I would have to look that up more. But that quickly I can kind of see, oh yeah, at least for now I don't want that. I just want that. And if I do that, it will work just dandy. And so there is for our specific problem. There was a more general problem, and we have those answers. So that's partial fraction decomposition. You could try some harder things like, okay, let's do a times x squared or x1 minus 1 squared. Let's try times x squared plus 1, since I know that's irreducible. And I'm going to get rid of this one because it's just going to get in my way. And so I left it as x plus 2 on top. And there you go. And just like that. And so notice for our irreducible, it does have a 3x plus 1. And now it must have, it was, I guess, 3/4 x and 1/4. That's where that 4 comes from down there. But then notice here, it did need the x minus 1 and the x minus 1 squared, both. It needed both of those terms to make this happen. It doesn't have to. I mean, if I created one that did not, that if I just took this 3x plus 1 over 4x squared plus 1 plus 1 over 8x plus 1, didn't do that, and then plus 3/4 over x minus 1 squared, got at my common denominator, got the right numerator for that, and then did the partial decomposition. Well, this term here better not show up because I didn't have it in there. And so an answer doesn't have to use both the x minus 1 and the x minus 1 squared, but this one did. Okay, and so that just shows you might need both terms to do that decomposition. So that's partial fraction decomposition within SAGE, And so hopefully that can help you out there. And again, you know, how do I search for stuff? I just go to Google. I start everything. Over the years I found start everything with Sage Math, and then whatever it is you want to do. And typically somewhere on the first page of the Google results I can find something. Now here I was a little surprised. Often when I see the doc sagemath.org and in this tutorial and so forth, whatever page that brings up works pretty well. I didn't find it. Now what I could do, I suppose, is notice you know, it says to compute, so it seems to think it found that in there. So what I didn't do when I went here, so there I'll go to that page. I didn't come over here and say find. Let's see, make this bigger. Oh, it doesn't make my search bar down here any bigger. So I type in partial derivatives, partial fraction. Okay, to compute. So I missed it, but here it is. So I should have been able to, you know, this is where I went first. They just have this one little line in there. I didn't see it, and so I went ahead and just looked at another page, but there you go. It was right there. And again, the sagemath.org tutorials, this stuff tends to be a pretty good place to go look. And so it was, I just got lazy in looking. I didn't try to do the find. I didn't notice this little statement down here that, yeah, it seemed to think that was in there. And typically I do that when I go to pages and I don't see something right off. I go to the find in page utility of my browser and I start looking for it. But there it is, and there's an example that's really, really close to our example anyway. And notice here that anything that says Sage in here, those are actual commands. And amazingly enough, if I simply do that, now this may show this because it's the last thing I do, so we'll see. But it will run that with Sage : in front of it. Now I usually clean that up to get rid of it. Let's see if it showed it. Now see, it didn't show it, but here I could just go like that real quickly and say show and do that and evaluate again. And well, that's not what I expected. That looks to be a problem, so maybe it did show that. So here's F. Now I defined F up here, but I defined it there again. Now typically it does run that, so just, you know, again, you run into some of these things, you know, I can fix them very easily, but I like to kind of know what's going on. And so I'm going to just get rid of that, evaluate, and see what it does. Oh, F is not defined. So maybe I lied to you. It definitely used to be that you could keep that word Sage in there. Maybe you cannot anymore. So see, it worked just fine. So there, I learned something in trying to do this. I have run this, I've run Sage code in these cells many times with the word Sage in front. So I'm gonna do that again and just see if it gives me an error again. It looks like it is because I don't see the typesetting sign. Yeah. So it wasn't happy for some reason all of a sudden. It may be an update on the Sage cell, but yeah, that did not work anymore. So you'll have to get rid of the word sage in front of those. So I'm glad I tried that. So now we see that we do need that. But now here I should get my two different answers because it does redefine F, and so I get the longer answer first, and then I get the shorter answer for this small, easier. I'll call it easier because there's fewer things to do. Easier decomposition here. Okay, so that will do it for partial fraction decompositions.